Hey everyone, and welcome. Today, we're jumping into some key physics concepts that are seriously so important, not just for acing that next exam, but for keeping you safe at home. All of this is inspired by the amazing Student Friend study notes, which are all about making learning click. So let's get right into it. So, does thinking about electricity, all those circuits, currents, and magnetic fields, make your head spin a little? Yeah, you're not alone. It can feel pretty complicated. But what if we could break it all down, piece by piece, into ideas that actually make sense? Well, that's exactly our plan today. We're going to make this stuff easy to get, and even more importantly, show you how it all ties back to staying safe. All right, first things first, let's tackle a really core idea: electrical resistance. You can almost think of it as the traffic cop for electricity. It's this fundamental property that controls just how easily an electric current can flow through something. And trust me, understanding what affects it, that's step one to getting the whole picture. Now, what's really cool is how logical these factors are when you think about it. A longer wire, that means more resistance. Kind of like running a longer race, it's just harder. Now, a thicker wire has less resistance. Just picture a huge, wide-open highway, allowing way more traffic to flow through easily. Of course, the material itself is a huge deal. Copper is basically a superhighway for electricity, while other materials are more like bumpy country roads. And finally, temperature. For most conductors, when they get hotter, the resistance goes up. And that heat, well, that's a really big clue when we start talking about electrical safety. Now, here's a fun fact. Electricity and magnetism are basically best friends. They're two sides of the same coin. The flow of electricity actually creates a magnetic field, and a changing magnetic field can create electricity. It's this amazing back and forth relationship. So to really get how our devices work, we also need to peek into the invisible but incredibly powerful world of magnetic fields. And guess what? They have their own set of very specific rules. So, rule number one for magnetic fields is that the field lines always form closed continuous loops. Always. They don't just start somewhere and end somewhere else. Nope. They flow out from the North Pole, loop all the way around into the South Pole, and then complete the journey right back through the magnet itself. It's a perfect, unbroken path of force. And this next rule is absolutely crucial. Two magnetic field lines can never, ever, ever cross each other. Why not? Well, think about it. A field line shows the direction a compass needle would point at that exact spot. So if two lines crossed, it would be telling your compass to point in two different directions at the exact same time. And that's just impossible, right? This rule is fundamental to how magnetism works. Okay, so we've got some of the theory down. Now let's bring all of this back to the real world, back to your house and your safety. We're going to talk about a really common household danger that happens when these principles of electricity, like resistance and current, get pushed way past their safe limits. Let's talk about electrical overload. And this explains it perfectly. An overload is, well, it's exactly what it sounds like. You're loading up one circuit with way too much demand. You plug in your computer, your heater, your TV, all into one socket. The circuit desperately tries to power everything, and to do that, it has to pull a ton of current. And remember what we said about resistance? All that crazy current flowing through the wire's resistance creates a dangerous amount of heat, and that's what can lead to fires. But here's the really good news. Preventing an overload isn't complicated at all. It just takes a little bit of knowledge and, just paying attention. So let's go over these super simple, practical steps you can take to make sure your home is safe from what is a totally preventable problem. All right, here are the 3 golden rules. First, and this is the big one, don't plug a million things into one socket. Simple, right? Spread the load out. Second, make sure your wires are in good shape. Inside a cable, you have a live wire bringing the power and a neutral wire completing the circuit. If that plastic insulation wears out and they touch, you get a short circuit, a path of super low resistance that causes a massive, dangerous surge of current. And third, always check your appliances. A faulty device can be a serious risk. And here it is. This is where all this brilliant, straightforward info came from, the original Student Friend notes. You can just see how these clear, handwritten points create a direct path right from understanding the theory to applying it for your own safety. It's all about making knowledge accessible and useful. So, as we wrap this up, what's the big takeaway here? It's that understanding these concepts isn't just about memorizing stuff for a test. The principles of resistance and the dangers of overload are directly connected. This knowledge is power for your exams, for sure, but way more importantly, it's a tool for your safety. And it all really boils down to this. The next time you're studying for a physics test, remember what you're really learning. Because while good marks on an exam are important, the knowledge that keeps you and your family safe at home, that is absolutely priceless.